We are going to be talking about centripetal acceleration. In order to talk about centripetal acceleration, we need to just do a little bit of review and go back to centripetal force. It is the force that is required to keep an object in circular motion, and we have used this equation already in the past, and so this should look familiar. So remember that the centripetal force, denoted by the big F sub c, equals mass times velocity squared all over r. And this equation comes from force equals mass times acceleration, where the acceleration here is v squared over the radius to denote that we are going in a circular motion. Remember that force is measured in newtons, which is a kilogram meters per second squared. Centripetal acceleration is center-seeking. It points to the center. It is how quickly an object's velocity is changing in a circular motion. So remember that velocity is pretty much, it can change either by changing directions, or it could be increasing or decreasing. So acceleration is whenever velocity changes, either directions or in the speed. And here we already have a for acceleration equals v squared over r, which we got from F equals ma. Remember that velocity is measured in meters per second, and when you square this, this will become meters squared per second squared. Radius, the letter r, will be in meters or in radius. Acceleration is measured after everything is cross-canceled. It will be meters per second, which is where we get the meters per second squared. Here is an example where you will need to do some calculations. Feel free to go ahead and stop this, just get the first part, and then try to solve this on your own before continuing. A 900 kilogram car moves at 10 meters per second and takes a turn around a corner in a circle, radius of 25 meters. Determine the acceleration and the net force acting upon the car. So we know that the acceleration equals v squared over r. First step that you want to do is just to list the variables and the information that you have and that you know. Here we have mass equals 900 kilograms. We have the velocity at being 10 meters per second. The radius is 25 meters. We do not know the acceleration, and we do not know the net force, but we should be able to find both. Step 2 is to solve for acceleration, and over on the left, you don't have to worry about writing this. I just wanted to have it here so that we could see what numbers I was plugging into the equation. So we know that acceleration equals velocity squared over radius. So when we plug everything in, we get 10.0 meters per second, all squared, over 25.0 meters. When we multiply and we divide and everything crosses out, we are left with 4.0 meters per second squared. Then all we need to do is step 3, solve for the net force. And we are using force equals mass times acceleration. We plug our mass in and we plug in our acceleration, and we get an answer of 3,600 newtons. Be ready to show your TNOTES in class and check Haiku for any extra home fun, and we'll see you in class next.